I like dinosaurs, obviously. I mean, look at my channel. And I like physics. You know, E equals mc squared, or E equals mc to the power of 2, or E equals mc exponential. Anywho, so I was thinking, I like physics, I like dinosaurs, and I haven't made a video since Newton discovered gravity. So how about a video about the asteroid, formerly called the Chicxulub impactor? Earth has been struck by many asteroids during its existence. The last significant one striking in 2013, Russia, over the city Chelyabinsk. The Chelyabinsk meteor, which was 20 meters and injured around 1,000 people from shockwaves, shattering windows, and striking with the force of 400 to 500 kilotons of TNT, or 400,000 to 500,000 tons of TNT. For reference, the Hiroshima bomb, which was only 15 kilotons, or 15,000 tons of TNT, while the Tsar Bomba, the largest nuke detonated, was 50,000 tons of TNT, and just 1 ton of TNT is enough to cause lethal shockwaves and destroy middle-sized buildings. While this most recent one asteroid, the Chelyabinsk, was 500 kilotons, the Chicxulub impactor, which killed the dinosaurs, was 72 teratons, or in other words, had the force of 72 trillion tons of TNT. A billionth of the Chicxulub's force is around 1.5 times stronger than the largest nuclear bomb detonated. And if you can't understand the fancy words I'm saying, the Chicxulub impactor, if it hit you directly, you would vaporize in 100 microseconds, or 100th of a second, a time shorter than the time the brain takes just to even process pain or touch. Meaning you would vaporize before even realizing what happened. Now enough about the force of the asteroid. What about the details about the asteroid itself? The Chicxulub impactor was approximately 10 to 15 kilometers in diameter, or 6 to 9 miles from my American cowboys. It was approximately 3,000 kilograms per cubic meter and had a mass of approximately 1. Okay, this number in the script is way too large. Let me see. 1 sec. I think this is 1.6 quadrillion or something kilograms. Yeah. And it struck Earth roughly 66 million years ago. The collision created the Chicxulub crater on Mexico's Yucatan Peninsula. And Chicxulub is just such a fun thing, I have to say it, and triggered the Cretaceous Paleogene Mass-Extinction, which wiped out approximately 75% of all species, including all non-avian dinosaurs. Recent studies show that it was formed far away from Earth in the outer solar system, and it was a carbonaceous or C-type asteroid, meaning it is common and contained many minerals and compounds and whatnot, including carbon and water. It struck at an estimated 20 kilometers per second, which is, for my American cowboy, roughly 45,000 miles per hour, at a steep angle of 45 to 60 degrees, which maximized the ejection of vaporized rock into and even beyond the atmosphere at 11 kilometers per second, which is approximately the same speed as the Apollo 4 spacecraft. Much of this was from the ocean, which, when the asteroid struck, the Yucatan bedrock and the water shot into the air as steam and aerosols, and this steam was not like in a shower. It could and can kill a human. It blasted a hole roughly 180 to 200 kilometers wide and 30 kilometers deep, and generated many immediate environmental effects lasting hours to days, including mega tsunamis reaching heights of up to 1.5 kilometers or 0.9 miles for my American cowboys. And that is thrice as tall as the largest tsunami in human history, which occurred in Alaska in 1957. The mega tsunamis from the Chicxulub scoured the seafloor and reached as far as 6,000 kilometers from the site, approximately the radius of the entire Earth. The impact also caused severe earthquakes of magnitude 9 to 11 on the Richter scale, and for comparison, the largest recorded earthquake was in May of 1960 in Chile. This earthquake of a magnitude 9.5 on the Richter. Though most would think the asteroid caused lots of heat, it actually caused a global winter for up to 15 years. Vaporized sulfur and dust from the rocks entered the upper atmosphere, blocking sunlight for up to 15 years. This halted photosynthesis for plants and phytoplankton. And phytoplankton was a big part of marine life as food. So, with no food for the marine life went kaboom. For up to 2 years, the photosynthesis was halted, and that caused global temperatures to plummet and fueled the death of many more surviving species, including plants and animals. In fact, if not for the extreme aftermath, dinosaurs would probably have survived. Not in large numbers, but there would still be a few, likely in areas far from the impact, like Central Asia. But these winters only happened after the global heat from the direct impact, specifically wildfires lasting for a few hours after the impact. So the winter didn't actually happen like 1 second after the asteroid. 1 second after the asteroid, you would burn instantly. The winters just happened a few hours or days after the impact. Debris ejected into space also rained back down, heating the atmosphere to several hundred degrees and igniting forests across nearly 70% of the planet, which is a lot of competition for loggers. Sulfur gases remained in the atmosphere for about 8 years, and fine silicate dust for around. I said dusk. Why is my speaking so hard? I think just that it's like a tongue twister or something. Anyways, and fine silicate dust for around 15, sustaining the cold and dark conditions. One natural disaster that happened seeming out of a movie. Acid rain. Massive releases of sulfur reacted with water vapor to produce sulfuric acid, which rained out for roughly a decade, acidifying surface, oceans, and soil. To simplify, sulfur and water vapor met and made acid, and the acid rained. Or simplify more, sulfur and water vapor had a baby and made acid. While these are the effects from the first 15 years of the impact, the next few thousands of years had effects too. Specifically, vaporized carbonate rock and gas from wildfires caused carbon dioxide levels to spike dangerously, leading to global warming. So, humans aren't the first, I guess. The Chicxulub impactor's existence was first hypothesized in 1980 by Lewis and Walter Alvarez after they discovered a global layer of iridium, basically an element rare on Earth but common in asteroids. It was above the layer of dinosaur fossils but under the layer of mammal fossils. The Chicxulub crater was then found in the early 1990s through data originally collected by a Mexican oil company called Pemex. And I don't know why, but that is just fun to think about, that a Mexican oil company called Pemex revolutionized paleontology and prehistory. That you can thank Pemex for your history books. Actually, no, not history books, like science books. They don't teach that history. This is a long topic, but why do they teach history of humans in school? I prefer the history of the plants and stuff. I think everyone does too. Like Atlantis. Why Confucius? Why China? Why Great Wall of China? Why the terracotta army of King Shi Huangdi? I think. Anyway, the impactor crashed in the Yucatan Peninsula at coordinates 21.333 and negative 89.5. And its crater is called the Chicxulub crater. Now used for study by scientists and as a tourist attraction. So, scientists study it and tourists look at it. Though the crater is now covered up by grass and rocks and whatever else covers it up. I mean, it's 66 million years old. Obviously, something's gonna cover it up. Anyway, one thing about the impact that is kind of freaky is the perfect nature of it. The angle it came at and the area it landed in, both perfect to maximize damage. The angle was what maximized the rock and other things launching in the air, and the Yucatan environment which bore sulfur-bearing rocks that significantly intensified the asteroid's effect. Now, if you look at the asteroid impact and look at the entire world, what was happening at the time, the more you look into it, the more you realize everything about this asteroid was perfect for everything to go kaboom. Speaking of the environment, it was and still is quite tropical in the Yucatan Peninsula, and not long ago it was home to the Mayans. For the Mayans, earlier I just said about the history, why did they teach history about humans? Yeah, now I'm teaching you history about the humans. For the Mayans, the Chicxulub crater shaped the Yucatan's famous cenotes, a fancy term for sinkholes. And the cenotes were used as a source of fresh water and bore cultural and religious importance to them, seen as sacred sites. Specifically, portal to Xibalba. I don't know if I pronounced that correctly, but that's basically just what they call the underworld in Mayan. Xibalba. Anyways, and they thought that the cenotes were the home of deities like Chak, the Mayan god of rain. They literally thought that the rain was down there. This isn't in the script, but I just think I remember this from somewhere. They thought that there was rain in the cenote, and the Chak dude just grabbed the rain and just threw it in the clouds and it rained back down. I think something like that. I don't know. Anyway, it was a prominent spot for rituals, including human sacrifice, which is very spooky. I mean, it's spooky that like every ancient culture did that. Anyways, much later, Spanish colonizers recognized its significance and built churches and convents over them for some reason. These cenotes were formed by gradual karstification of porous limestone bedrock. And if that's too many words for your little mind to understand, don't worry. It's too many words for my little mind to understand too. I'm a dinosaurist, not a geologist. This is geology. There's a lot of geology in the script. But anyways, to explain the words, porous means that it had holes in it, and it karstificated, meaning melted by slightly acidic water, specifically the acid rainwater thing. And this created large cave systems like in Minecraft. But unlike in Minecraft, gravity in nature existed, and they caused the caves to collapse because the caves became more bigger and the roof got unstable and they exploded. And the collapse then exposed groundwater. Millions of years later, due to the Ice Age making the ocean go crazy, the cenotes were filled with fresh water that the Mayans then used, though sometimes it also exposed them as open sinkholes. Now enough about geology and history and geology. What about the actual dinosaurs themselves? When the asteroid hit, we can't exactly be sure exactly which species inhabited the peninsula, and this is because basically all dinosaurs in that region at the time were vaporized. So, aka exploded. They don't exist anymore. Anyway, probable dinosaurs that lived there were dinosaurs like the T-Rex, Triceratops, Pachycephalosaur, and essentially all dinosaurs from North America. The most likely dinosaurs we know of to roam the Yucatan lived in southern North America or northern Middle America, which is a kind of a tongue twister. Far enough not to be severely vaporized, but close enough to sort of simulate the Yucatan. One thing these areas definitely can't and probably never have or will simulate is heat. As in the first millisecond after impact of the Chicxulub dude, the area of impact could have spiked to tens of thousands of degrees Celsius. And for comparison, the hottest recorded temperature on Earth is 56.7 degrees Celsius in Death Valley, USA. Where I live, in the winters, aka now, the temperature is around 8 to 15 degrees Celsius, while in summer, specifically July, they're around 30 to 45 degrees Celsius, which is much broader. But basically the first millisecond after impact was really, really hot. In fact, hot enough to melt the tungsten wall instantly, and tungsten is the strongest element we know of. The impact formed the superheated plasma, which is kind of cool since normal plasma is essentially superheated gas. While we've talked a lot about the area where the impact itself happened, what about the opposite side of the Earth? The side of the Earth directly opposite the equator, at least with today's geography, are the Deccan Traps, a massive volcanic plateau in west central India formed by huge basalt lava. Okay, my script says lave, but I'm pretty sure it means lava. Correct me if I'm wrong. Formed by huge basalt lava flows 66 million years ago. Quite the coincidence, eh? It actually is a coincidence, as the lava was caused by significant volcanic eruptions during this time, unrelated to the asteroid happening not long before the impact. Some scientists believe the one-punch, two-punch theory, which basically just says that the volcanism softened up the planet via volcanic stress, and then the asteroid delivered the final blow and kaboomed the planet. Some people actually believe that the Deccan Stratus caused the extinction alongside the asteroid. Ironic, since they both occurred on opposite ends of the world, again with today's geography. Most scientists think that they both worked together to cause the mass extinction. The volcanism was driven by a deep mantle plume, the Reunion hotspot, as the Indian plate moved over it, which caused prolonged fissure eruptions of basaltic lava. Fissure meaning a long narrow crack in the Earth's surface, and basaltic lava meaning if lava and basalt had a baby. This covered India with again my script says think basalt. I think it means thick basalt. Probably a mistake. And though this seems like a local disaster, it had severe global climatic effects. This process was happening for a very long time, but it only peaked 66 million years ago, in perfect timing for the asteroid. And with the asteroid helped make the climate very bad, specifically thanks to its release of both carbon and sulfur dioxide, which caused both global cooling and global warming, and sulfur, which was also in the Yucatan when the asteroid struck, caused acid rain. The carbon dioxide also acidified the water, killing marine life, and being a prominent reason why a mosasaurus didn't eat the Titanic before the iceberg got the chance. Dust and aerosols from the eruptions also dimmed sunlight and harmed photosynthesis, just like the asteroid. And this entire Deccan Traps volcanism thing is yet more of an example that the asteroid and every feature of its impact, including the mass extinction it and volcanism caused, maximized deadliness. Now for the physics that exists. Now one equation that summarizes the whole thing pretty much is E equals mv squared over 2, where E is energy, m is mass, and v is velocity. So to solve this, E is approximately equal to 1.6 times 10 to the power 15 times 2 times 10 to the power of 4 squared, 3.2 times 10 to the power of 23 joules, approximately. This is basically just an energy scale to describe three basic properties of the asteroid on impact: mass, energy, and velocity. All the natural disasters are consequences of this energy scale interacting with Earth and throwing everything out of order, or making everything go kaboom. The temperature was approximately -10 to -25 degrees Celsius during this time, and this describes around 15 years after the impact, when sunlight was blocked out and caused global winter. Now, while we know the dinosaurs were absolutely obliterated, what about mammals? Mammals didn't go extinct due to a combination of factors, including how they were small-sized, unlike dinosaurs who were quite large and big and chunky, since mammals then were much smaller than now, as they were rat-sized and lived in burrows underground. They were also nocturnal, which meant that they could avoid daytime fires and heat and stuff and things, and they were also warm-blooded, allowing them to better cope with the extreme temperature. They ate worms, insects, and detritus, aka decaying matter, which could be found underground and eaten safely, unlike other animals whose food has been vaporized, which caused starvation and death. And they used energy more efficiently and effectively, allowing them to survive long periods of time. After the 15-year-long major effect, mammals could live and roam freely, and due to the absence of predators, they evolved rapidly, which makes sense considering a super cool quote I thought of when writing this video script. A prey is weak only because it has a predator, and a predator is strong only because it has a prey. Anyway, moving on from that super sigma quote, the mammals, given there was no predator, became strong and chunky in sigma, and evolved in size, growing larger and larger over time. But then this gradually stopped when mammals evolved so many different species that mammals became other mammals' prey. Long ago, the cheetah and the gazelle were once essentially the same, but have millions of years of evolution. They are now rivals, one being predator and the other being prey. Even humans have done just this, since in the very, very early days of civilization, we did not fight one another as much. But now we have evolved many cultures and interests, and because of politics and diamonds and No, it's just politics, nothing else. We act like the cheetah and gazelle, both coming from a peaceful people, but slowly becoming predator and prey. And on that very deep note, that will keep you up at night very long and make you not sleep because it's super deep. I'm ending this video, so bye-bye. Okay, well, one last thing. I saw a super cool asteroid edit like at midnight yesterday, or today, so I'm just gonna link that in the description. Bye-bye.